Good evening, everybody, and welcome to the fourth and final of our online advice sessions for people who are supporting students with Down syndrome during the coronavirus pandemic. I'm delighted tonight to have with us Dr. Jo van Herwegen, I hope I've said that correctly, from the UCL Institute of Education, and Jo is going to talk to us about math development in children with Down syndrome. So I'll hand over to you now, Jo.
Thank you very much, Kelly, and thank you all for being here with me tonight. So yes, I'll briefly look at math development in children with Down syndrome. As some of you may already know, I'm an associate professor at UCL Institute of Education, and I've spent the last 5 to 10 years researching mathematical development in children with Down syndrome specifically, on top of other research areas in people with Down syndrome and Williams syndrome. So before I go and talk more about maths development specifically for people with Down syndrome, I thought it might be useful to run through what happens in mathematical development for typically developing children, just so we can see what happens when everything goes to plan. And I'm really sorry, what went right before, there we go. Did not work now. So a couple of milestones. One of the first things that may surprise you is the fact that actually number development in typically developing children, and probably also in children with Down syndrome, starts already in the womb from birth onwards, continues then as children can then outside of the womb hear and see things differently. So infants who are, newborns, who are very young, few months old, can already start to discriminate between small and large number numerosities or quantities, as we say. And then, so that develops from infancy onwards, that ability to discriminate between seeing maybe 2 objects to realizing that there is maybe 3 objects, etc. Another big milestone is then when children turn 2, when obviously in typically developing children, this is where we see language developing. And that's when then children master the counting sequence as well as the one-to-one correspondence. And I'll discuss later on what that means, that one-to-one correspondence, and why it is important. The next kind of bigger stage is when children enter preschool around the age of 4, where we see that children master addition and subtraction abilities at that stage, still with the use of fingers to help them work out the correct answer. And it's only until the age of 7 when actually a couple of these multiplication and number facts can be retrieved from memory, so that the kind of knowledge is becoming embedded. And it's after that age, so after the age of 7, by the time children are about 8 or 9 years old, where we see that children can do more abstract mathematical abilities, counting in 2s, counting in 5s, knowing all the timetables of the 2s, 5 and 10s, but also counting backwards, maybe from 1,000, or counting backwards in 10s, for example, which is a lot more difficult. So these are the milestones that we see in typically developing children. For most of us, I think, is when we talk about mathematical abilities, very often we then talk about counting, because it's obviously a core skill of mathematical abilities, but actually counting in itself is a complex skill, and there are lots of steps involved when children learn how to count. So first of all, children need to obtain an understanding that things can be the same in one aspect, but different in another one, and that these objects can be classified according to their shape or their color, how they are same, how they're similar, and how they're different. One of the things that's also important is that actually we can sort objects by quantity. So for example, if you see here on the picture, you see a couple of yellow blocks, Duplo blocks that have maybe 4, I don't know what you call them in English, but a kind of the tops on top. And actually, if you can see, it's a bit vague, but there's also blue ones and pink ones and red ones. So you could ask children to kind of sort these blocks, not only by their color, but also by the number of things at the top. Next stage is that children learn the counting names, and counting songs are obviously a great way of teaching children the counting names. At this stage, obviously, children don't know yet what these numerical or these numerals represent. At this stage, the children just learn what the number name sequence is. Counting songs are really good, and obviously there's also some available in Makaton for children who may struggle to verbally sing these songs. Next, children develop an understanding that when you count each object once and only once. And one way of teaching that easily is to make children move the blocks or the items aside, or to ask children to touch each object as they move through the counting. And my son earlier on tonight said, if you're not quite clear about whether your counting was right, you should then count it again and stick with the second answer when you've counted. And I thought that was a very clever answer that he gave. Next step involves the understanding that counting sequence stays consistent. So when we count from 1, 2, 3, 4, 5, 6, and that counting sequence is always 1, 2, 3, 4, 5, 6, not 1, 6, 2, 4, 5, for example. So again, it's important that children learn this stable order. And one way that could help them, because it links to developing a number line or an understanding of how numbers relate to each other, is, for example, by cutting out the numbers or asking children to create number lines, as you see on this picture on the screen. Next, children need to understand not only that counting always happens, when we have the counting sequence, it's always in the same sequence, but also that, counting has a particular meaning. And that is that, when you count, the last number you've counted represents how many items there are in that particular group or in that particular set. Now, children who don't really have this, what we call cardinality principle, which is the understanding of counting, they will just very often keep counting again and again. Or when you, for example, as here in the picture, if you give them a set of objects and you ask them to give a particular number, so as in this case, say, give me 6 dinosaurs or animals, children who have the cardinality principle will give you 6 and 6 items only, whereas children who don't really have the understanding of cardinality yet, they might just give you a random number, hoping that, they're close enough to the right answer. As I said, counting is a complex skill, so we're not there yet. The next step is conservation of number. So that means that children need to understand that the number of items stays the same even when you spread them out a little bit more. So obviously, as you can see in the picture here, in A, the top row and the bottom row both have 5 items in them. In picture B, what happens is the items in the bottom row are spread out more, but it's still 5 items and 5 items only. Another step that children need to learn is the fact that although in the counting sequence of the counting names always stay in the same order. But when you're counting, the order of which you count is actually irrelevant. So whether you count first with whether you start with the blue tractor on the left-hand side, or you start with the blue tractor at the top, that doesn't matter as long as you count all objects only once and once only. And then there is the abstraction principle. When we're counting, we don't just count objects, we can count anything. We can count sounds, we can count actions, such as this girl skipping, for example. And this is another thing that children have to learn during their counting development. Finally, and I think this is probably the most important one, is understanding in which way we are counting, so that when we're counting onwards, when we're doing addition, we're moving up the ladder. And if we're taking away, or we're counting that backwards, we're going downwards or decreasing. So this is what we call the movement magnitude. And the reason why this number line, or this understanding of how numbers relate and how we move along that number line as we're doing counting onwards, as we're doing counting backwards, but also as we're doing addition and as we're doing subtraction, helps children to understand what the correct answer is, or what they have to do when they need to do additions and subtractions. So here's just a short overview of all the different steps that children have to learn when they're counting. And obviously that means that there's a lot of ways in which children might, there might be lots of steps where children might struggle at certain of these steps and might need some extra help. I will come back later on to show you how, if your child is stuck at some of these levels, what you can do to help children move on to the next step. not only is counting and all these different steps are important, another very important foundation for mathematical development is the language, the mathematical language that comes with mathematics. And I've just summarized for you a few of the words that I could think of that, you know, are related to mathematical development and are words that we may use when we teach children about maths. And as you can see, there are a lot of words on this screen. So what is very important is that children throughout their education learn or keep learning and keep hearing all of this mathematical vocabulary. And for some children, that means we might need to teach this vocabulary explicit rather than maybe some typically developing children might pick them up as, you know, they go around their daily lives. But for some children, for example, very young children will struggle with things like spatial relationships in, under, by, besides, etc. So these are some mathematical specific aspects that children need to learn as the foundation of their mathematical development. So we're thinking about counting, strategy use, math facts, etc. But there's actually much more to mathematical development than these mathematical specific things. And these are the fact that we know some of the domain general abilities. So these are abilities that we use throughout other tasks, language tasks, other daily tasks as well, or learning abilities. And I'm thinking about working memory, visuospatial skills, and especially inhibition. So the reason why working memory abilities are important is working memory abilities is the ability to hold information in memory and manipulate that information so you can find an answer. And if you think about mathematical abilities, very often what we do in maths is, for example, adding two numbers, which means you have to keep the two numbers in mind and then manipulate these in order to find the right answer of your addition. Also, visuospatial abilities are important. I've showed you in an earlier slide that this number line is very important for mathematical development, knowing whether you go up the line or down the line. And your visuospatial abilities are your abilities to know how one object or yourself relates to your environment. So this relates to puzzle making, but also to finding your way around when you're in a room or in a school. And we know that's very important for mathematical abilities. So one of the things that we know that helps visuospatial skills is playing with Duplo and Lego blocks. But related to visuospatial skills are actually motor skills. Because one of the things that happens is when a child moves from lying down as an infant to sitting up, or from sitting up to walking, that the child's perception of their environment around them, but also how they see themselves in relation to the environment or interact with the environment will change. So this kind of like your motor abilities will impact on your visuospatial abilities. And your visuospatial abilities in turn are important for your mathematical abilities. Also, of course, your motor abilities in maths, we often have to write things down to work things out, or even, you know, when we're counting and we need to point at each of the items to be counted, that obviously requires motor abilities as well. Inhibition, the reason why that is important is because obviously when we are thinking about maths and we're thinking about finding the right answer, that means we need to inhibit all of the incorrect answers. And for some children, and especially young children, that might be difficult as well. So we have some mathematical specific skills that we need for mathematical abilities. We have some general cognitive skills that we need to develop mathematical abilities. And then there is this final ability that some of us think are innate, or at least we know it develops from very early onwards, is this number sense, understanding how numbers relate to each other. So that's what I wanted to say about development in typically developing children or in general, and I now want to talk more about what happens for children with Down syndrome. I'm sure most of you are very familiar with the difficulties or the strengths that children with Down syndrome have. But I'm just pointing out a few that are maybe relevant to mathematical development. So first of all, we know that many children with or individuals with Down syndrome have issues with working memory, so holding ability in short-term memory and then manipulates that information. We also know that many children and individuals with Down syndrome have delays in their language development, but particularly might have difficulties with their speech, a bit like I have today as well. And that's finding it really difficult today to talk. We also know that children with Down syndrome have difficulties with sustained attention, and that's something that might not be so widely known, but we've completed over the last few years a few eye tracking studies, which I'll show you later on, to show what that means in terms of how children with Down syndrome move their eyes and what that might mean for mathematical development. And then related to working memory, we know that many people with Down syndrome have problems with their short-term memory. So just keeping information in mind in a very short time before they can manipulate it. And finally, related to mathematical development are the delayed motor skills. But obviously there's also strengths in people with Down syndrome. For example, the fact that they have strengths in visual processing, but also in their long-term memory. So, and as I mentioned earlier on, visuospatial abilities, we know that actually they are quite a strength for individuals with Down syndrome as well. Although language development might be delayed, we know many individuals with Down syndrome can use gesture appropriately to make themselves understood and to answer questions. And we know that there's a general strength in social understanding and also, liking being with others as well. So what do we know about number development in individuals with Down syndrome? When it comes to the number sense, which is this understanding how numbers relate to each other, which we know in typically developing children develops from birth onwards, we've shown both in infants with Down syndrome as well as older children and adults with Down syndrome that the ability to estimate large groups and see differences. For example, here you see the picture between two different numbers of monkeys, and when people are shown this, they have to very quickly say which picture has most of the monkeys in it or more monkeys in it, so it's the one on the right hand side. We know that even infants with Down syndrome can do this quite well, and there's no issues there. Quite well, I need to say, it develops in line with their nonverbal ability. So there's a little bit of a delay compared to typically developing children, but it's a task that they can do quite well and accurately. The only issue is that in typically developing children, this ability, how well you can discriminate between large numerosities, is a very good predictor of how good you're going to be in general mathematical abilities. Whereas in individuals with Down syndrome, we do not see this relationship. So that means that although they're good at this large number sensibility does not relate to their mathematical abilities, and it must be something else that we need to look at to help people with Down syndrome improve their mathematical abilities. One of the things that a number of studies have shown, including my PhD student, Erica Ranzato, is that when it comes to estimating small number, we see that people with Down syndrome have some difficulties, and that they, rather than using their automatized processes, that they revert back to counting. So when, for example, you're playing a board game and you're rolling a dice, very few of us have to count a number of dots here in this dice-like pattern of 5. We can immediately see that it's 5, compared to when items are randomly distributed or shown in random patterns, and we often have to revert to counting. We can't automatically recognize it. So what we see in a number of studies is that individuals with Down syndrome, they always count the patterns even when they're arranged in a dice-like pattern. And obviously that means that they might need extra time to complete tasks, because they need to revert to counting, which is more time consuming compared to using your automatic recognition or pattern recognition abilities. When it comes to counting, again, this is work that Erika Ranzato is completing. And what we've seen is that individuals with Down syndrome, and in this study, we looked at children and adults, so quite older participants, we found that they found it really difficult sometimes to name the number names, which obviously we knew can be a difficulty for some of the individuals with Down syndrome. But there were also some difficulties sometimes with recognizing digits or knowing in which order number names should go in general. Another issue that we've seen, and this was through the eye tracker that we used, was problems with one-to-one correspondence. So making sure that each item is counted once and only once. And so a number of the participants were, when they were making counting errors, were not only making counting errors by using the wrong name, but also by counting things twice or skipping items in their counting. And we know that that relates to some of the verbal difficulties that children with Down syndrome may have in general, but also, as I mentioned before, attention difficulties. So the blue lines, what you see on this picture, is one of the things we've shown people with Down syndrome, and we asked them to count a number of dots. And what you see is that there is a lot of, all these little blue dots are places where the eyes of the participant were landing on the page, as it were. And all the lines was how they moved across the page. And generally what we see in typically developing children, but unfortunately I couldn't find a good picture, is that we only get 1 or 2 looks at not all the dots, just some dots. And they quickly scan a couple of sets and be able to say, yes, these are 8 dots. What we see here is typical for an individual with Down syndrome. There's lots of little looks, not being able to keep track of where they've been already with their eyes and where they need to look next. When we then, so far we've been talking about, you know, your early number foundation skills, such as the number sense and knowing the counting names. When we look about, you know, what about more advanced arithmetics in individuals with Down syndrome? I'm referring back to a study from a while ago by Sue Buckley and colleagues in 1987, because they had a really good number of people with Down syndrome involved in their study. So they had 90 children, I believe, between the age of 5 and 17. And what they found was that only 50% of those participants were able to solve simple addition problems. However, a more recent study by Elisabetta Martinez and Nives Benedetti, who are Italian researchers, they looked at 2 case studies in Italy, and those were 2 10 and 11-year-olds who were in a mainstream class in Italy. And what they found was that when these children were taught how to solve addition sums in using logical steps, and they did it in a way where there was lots of motivation, so with, you know, with others involved or with an adult next to them. And when these 2 cases were given a lot of time and a lot of practice, they did manage to solve problems, including fractions, I believe, and they were able to learn integers. So that shows that although there may be some people who have difficulties, it is possible for some people to learn these advanced mathematical or more advanced mathematical addition and subtraction, but also multiplication and division abilities. What about overall mathematical abilities? So what we see here is that we did a study. It's only 24 or 23 participants who individuals with Down syndrome. There was a wide age range, and we did that on purpose because we wanted to see whether it is the case that maybe whether there is sorry about that, I need to think of the word now, what is kind of a ceiling in mathematical development, or whether mathematical development continues but is just much slower over time. And that's exactly what we found. So we found that there isn't kind of a ceiling effect. There isn't kind of so at the bottom here you see the raw score, which was how many points these participants had on a mathematical ability task. And what you see here is that, you know, there isn't kind of a ceiling. There is continued development. And what is the case is that those who were older, or those who had better nonverbal abilities, were also those who had higher mathematical abilities. So mathematical abilities continue to develop in line with nonverbal abilities. So what predicts mathematical abilities in individuals with Down syndrome? We do know that most of the abilities develop in line with nonverbal ability, but the question we were asking, and not just us, but also other people, is if you want to do an intervention, if you want to raise mathematical abilities, what kind of skills, either domain general or domain specific skills, would you target? And what we found in our recent study that was published just a few weeks ago, we looked at mathematical development in a number of individuals with Down syndrome and looked at a range of domain general and mathematical specific abilities. And there were two abilities that strongly came out of what predicts people's mathematical ability. And that was visuospatial abilities, which is quite a strength for people with Down syndrome, and number familiarity, which we know is a difficulty for many people with Down syndrome. In another study, which was by Lemons et al., which is a systematic review, so that's kind of looking at, if you look at any of the interventions done with that target mathematical abilities in people with Down syndrome, what do you find then? So Lemons and colleagues found that there were 9 intervention studies that have been done so far, so it's not many at all. And from what they found in their systematic reviews, these 9 studies mainly focused on counting. And the good thing is that when you focus on counting, you find that the abilities, the mathematical abilities for people with Down syndrome improve. So based upon those 2 findings, what we think is happening is that, of course, if you help children to count and keep practicing their number names, people with Down syndrome's mathematical abilities will improve. But also what we think another way of helping mathematical abilities to develop for people with Down syndrome is to maybe also think about visuospatial training or playing with Duplo blocks, for example, which we know raises visuospatial abilities, as well as maybe early motor development physiotherapy. Moving on forwards about, what can you do in your school or at home to help your child with Down syndrome? One of the things is daily practice, because mathematical abilities for individuals with Down syndrome develop in line with their nonverbal abilities, which means that it takes them a little bit longer, but they do get there. So practice is key. Best practice would be in short bursts, included in daily activities. And so what we've done is in my lab together with other people, and again, Eric Aranzato, is to develop these games that can be done at home. They're not formal games. You don't need a table. You don't need a pen and paper. We have games that you can do in the bath. We have games that you can do at a dinner table, in the car, when you go for a walk. And all of these games target particular aspects of mathematical development that will help your child. You can find more information about the games on our website and on our Twitter account, which I'll give you later on. Next, I know it's often not seen as very much fun, but we do know that people with Down syndrome struggle with kind of this automatic access to number facts, and that means drilling and rote learning, unfortunately, are key, because it will allow people with Down syndrome to free up working memory space to then actually carry out the sums, the additions, the subtractions, etc. So the mental processing that is required for the mathematical task. And that means, overlearning. One of the existing types of therapies or interventions is a Kumon intervention, and that focuses a lot on rote learning. It's a teaching program that it emphasizes a step-by-step approach, and then you build on success and learning through practice so that motivation for the child keeps high. Now, these ones are on your classical worksheets, and I'll come back to that. So it does require paper and pencil. However, we do know that people with Down syndrome learn best when there's visual support, so using tokens like this child is using here could help, but also the use of 10 frames. And I know there was a question about the use of 10 frames, in that, you know, it can be very difficult. Indeed, it will take some time, because I think we need to make sure that children with Down syndrome are shown how to go through this step by step. So the fact that this is one row has 5 empty spaces or dots in it, and then you have a second row which can have 5 in them, but in this case only has 3. But kind of to explain first before they do anything, this is a 10 frame. A 10 frame is 5 dots and 5 dots, and to keep working on that. Another way of using visualization in word problems is to kind of break it down and to kind of say, if you add 3 plus 2, the child can write them down or sign them. But it's kind of using that visual support that helps the children's working memory. That is very important. As we mentioned before, because the fact that some individuals with Down syndrome have this problem with sustained attention, so keeping track with their eyes of what they've counted, we need to make it clear that they should pay attention to particular aspects. So that means as teachers, we may mount a point as where they might need to pay attention to which part it is, or we use other gestures to kind of make it clear what we're doing first and what we're doing next, for example. But also spacing things out will help people with Down syndrome to kind of keep track of all the different options, especially when counting or when they have to do sums, to know we're first going to pay attention to this number, then here is a symbol, and then here is another number that we're going to use in our addition, for example. So the way you space things out, as I mentioned before, matters. So obviously it's more difficult to count objects that are arranged in a circle or objects that are arranged randomly, as you can see at the bottom, compared to when you arrange objects in a line or in a dice-like pattern. One thing that I may have said already is breaking things down will help individuals with Down syndrome. So one of the things I'd say is that when you ask them to solve a sum, such as 3 plus 6, for example, you might actually want to rewrite that as an empty box, so that they can say, right, first we need to look at the first thing, which is your 3 here. And 3 actually means 3 dots. Then we look at the next thing, which is a plus symbol. That means we're going to add. Adding means going that way on the number line. So in some people would also add a number line underneath this to kind of make it clear to the child where they're going, basically, in what direction. And then obviously you would do the same for 6, asking the child to draw 6 dots or move 6 dots if they find it difficult to hold a pen. To then, you know, then they can use these objects to come and work out the right answer. And so part of this actually is also explaining to children where they need to start first. So where would you start looking? What's the first thing you see? Because we as adults find it quite normal that, you know, we read from left to right and that 3 is the first number and then plus is a symbol. But for younger children, that might not be quite as straightforward as we think, or quite as obvious. Another thing to think about is allowing for non-verbal responses, or practice that doesn't require a child to verbally respond or to respond in a written format, because that will take more time and effort. And when things take time and effort, it takes a longer time and it's often more boring. So for example, doing number lines, and rather than for a typically developing child, we, for example, would give them 4, 6, 8, and then 12, and then they'll have to write the number 10 on it. For individuals with Down syndrome, you could adjust this and just say, here are 3 numbers, which one is the correct one that should go in this missing space, for example. There was also a question about use of a calculator. And I think, you know, because a lot of children with Down syndrome are struggling with their short-term memory as well as with their working memory, I think the use of a calculator is a fantastic tool and solution. It's a solution we also advocate for people who have dyscalculia. And we often say children with dyscalculia should have access to a calculator to help them. And I think the same should be the case for individuals with Down syndrome who may benefit from the use of a calculator. Even using a calculator requires a lot of mathematical skills, such as recognizing the digits, but also if you want to do addition or subtraction or division on a calculator, you still need to know the order in which you put in the numbers and what your symbols mean and when you press which symbol. So when you, for addition, that you know 3 plus 6 equals, and then the calculator will give you the right answer. But the steps, so if you want your child to know what are the steps to take in order to solve problems, a calculator is a great way to teach children how to, which steps to take, basically. So these are a couple of general things that can apply to any kind of mathematical task that you and your child are doing, that would help children with Down syndrome. These minimal adjustments can make a big difference. And obviously all of these, when we make things accessible, when we make things a little bit more fun, a little bit less draining, it will keep children's motivation high. And we know that that's one of the most important things for learning for anybody, is that, if it's boring, people will not do it. And a couple more questions or answers to questions to finish up is, there was a question about the use of Numicon. And for those of you who are not familiar with Numicon, it's a multi-sensory scheme designed to teach originally typically developing preschool and primary school children. And it uses these visual, these toys or objects to help visualize, for children to visualize how the numbers or amounts relate to each other. So at the top you can see, what a 1 is a 1 orange one, a 2 is 2 purple ones, and etc., etc. And so given the visual strengths of many children with Down syndrome, it's thought that Numicon can be an effective aid to help them learn number skills. And there has been, I think, 2 RCTs now for people with Down syndrome by the Portsmouth group, where in the first study, they had a small RCT where they found positive impact of the use of Numicon. So they had a couple of children with Down syndrome who were using Numicon, and then a couple of children who were just using business as usual in the classroom. What they found was that children who were using the Numicon made greater advantages or had better performance than those who were not using Numicon. When a larger follow-up study was done, they didn't find those benefits in mathematical ability per se, but still teachers did have a lot of positive things to say about Numicon, because again, it kind of, the materials are motivating, there's a clear teaching structure, it helps with the count word sequence, but also really the understanding. So there was also, teachers also reported that when they were using Numicon with their child with Down syndrome, there were also other skills that improved other than numeracy, including motor skills and pointing and gestures, etc. So, Numicon can be something that can be quite helpful. Another existing intervention, but it's not one that many schools are using, is touch math. And what happens in touch math is that, you get these symbols and there are then dots put on them so that these can help the child recognize the digit, but also understand what the digit is for. It's also an intervention that uses a lot of different steps to make it easier for the child to know which steps are we using in order to learn. The evidence for touch math is not so strong. There is some evidence that it can help counting early onwards, and addition, but only up to 5, because I think after symbol 5, then the dots and the symbols become less, become a bit more abstract, and obviously that there were the different issue there. I've introduced Kumon already earlier on, which is about rote learning. That can be beneficial for some people with Down syndrome, because we know that they have difficulties with the automatically recognizing and so rote learning and overlearning step by step can help. Another one is stern structural arithmetic. I'm not so familiar with that one. This is a program for learning number concepts that is based on reasoning and insight into mathematical relationships, using then rote learning and counting only. I think my personal view on this is that using one system alone, whether it's just rote learning or just, doing mathematical abilities within daily life, you'll probably need both. Children sometimes need to learn things in a very structured way before they can then use it within their wider daily activities and environments. But in the other hand, if you have just learned things to do it on paper and pencil in the classroom and never applied it to anything in real life, then probably your maths abilities are not going to be useful to you in the long term either. So I don't think it's either or, I think it's probably you need both. So overall, what I want like you, or what I hope I've made clear tonight, is that mathematical development is quite complex. So mathematical development depends on a number of domain general abilities as well as domain specific abilities. And if we want to raise mathematical abilities in any individual or in individuals with Down syndrome, we need to not just think about how can we raise number, naming, sequence knowledge, or how to do additions, but also think about the vocabulary that we're using and teach children some of that vocabulary explicitly, or make sure that children at least know that vocabulary, but also some of the domain general abilities. So, for example, help improve working memory abilities, help improve motor abilities so that they can count and keep track of which objects they've counted and which ones they have not. And also because we know that over time, from infancy onwards, these pathways interact with each other. So, we need to think about what are the prerequisites that the child needs to learn before they can move on to the next step. So it's really difficult for children to go and do addition if they haven't really grasped on how of what the number naming sequence is, or how stable that number naming sequence is. So meaning that if they don't really have an understanding of all the numbers and how they relate to each other on a number line, they will find it quite difficult to move on to addition or subtraction, because they wouldn't know which way we go on the number line yet. So practice, practice, practice to help with automation, because otherwise children with Down syndrome may struggle because of working memory difficulties. So overlearning can be a good thing, but obviously we also need generalization, and that means, thinking about how mathematics can be applied in real life. I've talked already a lot about maths vocabulary. I'm quite a big fan of maths vocabulary. I think it's very important to teach children that. And thinking about use of tools, but also visualization tools that help reduce working memory and language demands. Because as you probably know, or at least in my experience, very often we underestimate individuals with Down syndrome, and they often can do things when we give them more time, but also the appropriate ways to respond or tools to help them. So thank you all very much for listening to me tonight. Obviously, what I've told you tonight relates to a lot of the work that has been done with participants, their families, but also with my collaborators. And obviously, I have to thank the funders who have funded our research. And I'd now welcome any questions.
Thank you, Jo. And I'd just like to add to what you've said this evening, given us a lot of information. One thing I'd just like to add is to say, children do find learning maths difficult, but there's lots we can do to support maths development, and there are many supports that we can put in place, and when those good supports are in place, children can do really well with their maths learning, and that's really important to remember. So you've had loads of questions come in this evening, so we'll go through some of these if that's okay.
Yeah.
The first one to say, so the child can do additions, subtractions, but then they can't recall the number, the answer to write as the answer. So how can I support him to record his answer correctly? He knows the answer, he just can't recall it to write it down.
Yeah, and this relates to the short-term memory difficulties that some people with Down syndrome may have. And then my question is, would they need to record it by writing down, or can they visually record it or point to a picture? Because in the end, that's what's important, is the fact that they knew the answer. What's frustrating then is that they've forgotten it. So this is maybe, is there another way we can think about for helping this child that it's not about writing down, but it's more about finding the right answer? And it could be, that someone verbalizes it still, because then you still need to transfer your verbal number word to a written number word. And that's yet another skill. So if, for example, the adult or the teacher can say, well, you told me the right answer was 14. Can you write down 14? And just, then see whether they can write it.
Great. Okay. So we've had lots of questions on chat about Numicon, but I know you spent some time talking about Numicon. So because we've got lots of other questions, we'll move on. Would you introduce the clock and money?
Can I just say one thing about Numicon? I know there's lots of people who do find it works and people who find it doesn't work. Very often when it doesn't work is because the child might not have necessarily the right vocabulary. So Numicon is just a tool. You still need to tell children about what does more mean, what does one more mean, what is addition, and if the child can't grasp that, that's probably why Numicon is not so successful.
Thanks, Jo. Would you introduce the clock and money/coins to a child who can only count 1 to 6? The child is 9 years old.
So I would say this child is still very young and is probably not there yet to move. In order to introduce the clock, you need to be able to count into fives almost, or understand, because we're going up to 60. So obviously, using a digital clock will be much easier for children to start recognizing numbers. But I'd say a child who can only just recognize single digits, they're going to still struggle with the understanding. I'd say when I work with younger children, I would give the same advice and say, still give them a clock. I'd still point out the numbers over time, because I know it's a skill that will develop. It will just still take a little bit longer.
Thank you. Okay, we've got a question here about a child who has suddenly begun to forget numbers 8 and 5. So previously they were counting up and down to 20 quite successfully, and then these numbers just seem to have disappeared. Any idea why?
No idea why. I'm really sorry. It's uncommon for children to kind of unlearn things, but yeah, I don't know. I really don't know. It's a fascinating one.
Maybe one for another research project.
There you go.
Okay, there's a problem this person would like some help with. The child is counting verbally whilst touching objects, but they're counting wrong. So for example, 6 might be counted as 8, as the verbal part isn't moving at the same speed as that which they're touching the objects. Any tips for getting them to get that right?
Yeah, so the thing is that these children are still struggling with just the number and name sequence. So basically you need to go a step backwards and kind of keep practicing on that number naming sequence. So the songs, as we were saying, and just keep practicing that. That means that it's just not, the access to the number names is not automatized enough, so that it can be accessed quickly enough when they're actually counting.
Great. Okay.
I'm not sure. Sometimes for these children, it might help if we ask them to count silently and then to give the final answer, so that they don't have to spend the time and effort on verbally giving all the number names.
Okay. This child has numbers to 20 and they're getting there with simple subtraction and addition. What are our next steps?
It would be starting to understand division and multiplication. So that is half and doubles would be the next step before going on then to fractions and multiplication tables. So really, again, working on what does it mean when we do multiplications, when we do doubling things, tripling things, quadrupling things, and also half, quarters, etc. And again, it's all about starting simple with the language. I think, you know, we often forget that, you know, children don't otherwise understand how we're moving up and down that number line. So when you're kind of saying, and again, we have some of the Maths at Home games have practice in there for understanding doubling and halving, what that means in terms of also using visual tools. Fingers are a really good one, by the way. One hand is 5, you double it, you get 2 5s, it's 10.
Oh, well, that leads me on nicely to the next question, because somebody has asked for some examples of the games that you were talking about in the talk.
Yes, so one of them, it's asking your child to help up washing up when you know, you've got socks to hang up, for example. They have to find pairs, and then they have to count the pairs of the socks that they found, for example. When you're in the bath, you know, you can do things with doubling, either with liquid if you have 2 measuring jugs, and you can ask them to half the water or double the water. But as I said, you can use fingers and toes for that one as well. When you go for a walk, you can do I spy a number. You can do that in the car as well. You can at home do a treasure hunt, where you ask children to kind of find 4 of their favorite objects or 5 of their favorite objects, and that helps with cardinality. I think in the end we came up with about 40 different games that you can easily use within the home or even school environment, obviously, as well.
Can people find those somewhere, Jo?
So at the moment, we're reworking them into an accessible, probably app, and if not app, a booklet that not only explains the games, but also what it's training and why and what the different steps are. Because one of the things that we've realized is that some games work better for different children, and it depends where, again, in that development that they are in their mathematical development. So we want to spend a bit more time on creating them. But if you go to our Twitter, my lab is the CDLD lab. On the Twitter account, you can go back, because we did them all throughout lockdown. Every day we did one game, and they're still on our Twitter account.
That's great. Question from a bilingual family: should they only use English when teaching maths, or is it all right to use their second language as well?
It's all right to use second language as well. It's fast. It a little bit depends on what the second language is, because
it's
we have
Hungarian.
Sorry, it's which one?
Hungarian.
Hungarian. So Hungarian, as far as I know, I'm not a native speaker, is that they have a more, so different languages have more transparent counting systems. So for example, if you count in Arabic or in Chinese or in Welsh, number 1 and number 21 and 11, they're all related to each other. So once you know the numbers 1 to 10, 20 in Japanese is 210, for example. And so it becomes quite clear for the child which number you're talking about. Languages such as English, and especially my own native language in Dutch, we reverse some of the numbers, and it actually means the opposite. So in Flemish, you would say 1 and 20, which means it's very confusing for a child when you're actually talking about 21, but you're saying 1 and 20. Hungarian is very transparent, so it wouldn't hinder, you know, because you wouldn't kind of make it harder for the child. You wouldn't confuse them.
Okay, lovely. I think probably last question, Jo. How do we encourage math development for a 16-year-old? So they've tried Numicon and cubes. Any other techniques that you might suggest?
It depends on what level, what is the child struggling with at the age of 16?
I got the impression that the child really hadn't got very far on at all. So they're 16, but I think probably quite early in terms of math development.
Yeah, so I think it's a question of getting that a lot of number line development. So because it's kind of getting that sequence of the numbers correctly, and even if they can't do that verbally, recognizing the numbers in which order they need to go, helping to build a number line is a very important aspect of mathematical development.
Thank you, Jo. One last thing, some people have asked for your Twitter account name.
Yes, I don't know whether what's the best way to write is, I'll write, can I go into the chat and maybe write?
You probably can, yeah.
Well, if I know, wait, if I stop sharing, then it might help. There you go. Now I can go in the chat. I wasn't able before. And if I go, sorry about it, my screen's got too many things open. Okay. There you go.
Okay, that's great. I'll just share that with everybody because I think that's just come to me. So let me just send that
Oh
down
yes,
to
send to
everybody.
you privately. Yes, sorry.
There we go. Okay, thanks so much, Jo. Thank you very much for that. So I know that lots of you had asked questions that we didn't get a chance to ask Jo in the session. But just to say, Jo has very kindly said she would be happy to answer your answer emails from people. So I know Jo's email address was on the slides up there while we were doing the chat. So thank you very much for that, Jo. That's really, really kind of you to offer that. So that's the last of our planned online advice sessions. And I really do hope that you found them useful. We set out with the aim of providing you with some practical strategies to try at home at this time, and I hope that this has given you at least a starting point to get going. So as always, final messages from me. Firstly, the recordings will be available from all of the sessions next week. So we'll spend tomorrow putting those together, and next week we will send out some information about how to access the recordings. Okay, that information will be sent out to you via the same channels by which we advertise the sessions. So you will get that information, and because you're a registrant, I have your email address and I'll email you that information directly so you can access those recordings from next week. If you're watching the recordings, please fill in our evaluation surveys, and also for you guys as well, we'd really appreciate it if you would fill in our evaluation surveys from this week. As you know, they're really important to be able to demonstrate that what we've tried to do this week has been useful, and that might help us in the future be able to do something like this again. So they're really short, the evaluation surveys. It won't take long, so if you do get a chance, please please go on and fill in that survey. I've put the link to the survey in the chat function, so you should be able to access that directly from there. The last thing I want to just say is a thank you to Stephanie Hargreaves, who has helped me for the last month set these sessions up. It's been quite a big job and I couldn't have done it without her, so thank you very much to Steph, who I think is on the session this evening. And a last thank you to all our speakers this week, who have given us some fantastic ideas to try, and some great suggestions and sessions. So thank you so much, and thank you to you for registering and for taking part. It really has been great to see so many of you on these sessions. So thank you very much again. And I've said all I need to say, so I'm going to sign off and say good night, everybody. Keep safe, keep well, and look after yourselves, and hope to see you again at some point. Bye, everybody.